f naught. Watch out, one more thing I want to point out. I have f naught divided by s, which means that s character has to be in the denominator at the end of the day. Okay, so it has to be s times tau s plus 1. I cannot write this as the following. I cannot do this. That's wrong. Okay, please notice this. And that's the idea of partial fractions that can be used later on. So this is f naught s times tau s plus 1 plus tau x naught tau s plus 1. Take the factor tau as a common factor so that x of s is f naught tau times s times 1 by tau the factor of tau cancels in the top and the bottom. We're almost there. But you can do the following. I can take this tau, which is a constant, and I can attach it to the numerator because that creature is just a number for me. Okay? And so if I do this, this is now x forced of s. This is x free of s. Look at x free, it's the same form as before. Is x naught by, I don't need to do any calculations, we just did all this hard work. Just take the value from before. We already did all this. Can't do the same for x forced, I have to use partial fractions. Is f naught by tau s plus 0 s plus 1 by tau. This is the only problem. I'm going to use the partial fraction method. For the next responses and so on, we are going to use MATLAB, or I'm just going to tell you how to do it. Okay? This is real and distinct roots. So this is some C1 by this is how you do it for real distinct roots. Then you cross multiply both sides so that you get f naught by tau is C1 times that and C2 times s. S plus 0 is the same as s. You substitute s is equal to 0, you substitute s is equal to 1 by tau negative. I will get C1 to be equal to f naught. And C2 to be minus f naught. So that this is nothing but f naught by s minus f naught by s plus 1 by tau. Just bear with me for a few more minutes. I'm going to erase this portion of the board. Okay, everybody has it? Okay, some of you are sleeping, so I'm not sure how you have it, but I will take your word for it. All right. I take the inverse Laplace of all of this. So the inverse Laplace of t is f naught times the unit step one day when somebody is sleeping, we should all just silently leave. And then we'll happen. All right. F naught times u of t, and then I have minus f naught e to the power minus t by tau. And in the past, when people were sleeping, I would throw my chalk. But I'm worried about legal action, so I don't do that these days. Okay, so I won't do it, don't worry. All right, so the total system response is x forced plus x free. I just want to make one last point, okay? This is now x forced, which we just already have here. Laplace inverse of 1 by s is the step function. So your input was f naught times u of t. You also get that as one of the outputs, which is quite interesting in my opinion. Okay? Minus f naught e to the power minus t by tau. This is the forced response. Bring in the free response fellow. He's just sitting there minding his business. This same thing, I can also split it in the following manner. Okay, so this is x forced, this is x free. I can collect all the terms that do not vanish as time goes to infinity, which is f naught u of t. That's the only term that does not vanish as time goes to infinity. The rest of them will go to 0 because of the exponential decay. So this is the steady state response. I'm going to write that statement somewhere here. This guy is the transient response. And this is steady state. So keep one thing clear in your mind, steady state behavior is not the same as steady state response. Okay? The steady state behavior of the system could be tending to reach somewhere. The steady state response is a part of the response that does not disappear when the system goes to 0. Thank you very much. Have a good day.